Hi, folks. So this is a discussion about the moon and our observations of it. So phases, lunar and solar eclipses. One of the questions that we'll have is why we only see one face. So let me remind you that we really don't get to observe the moon very much. Certainly you can, but in our typical daily affairs, we're in a house in the dark. Uh, and in the house it's lit up and all that, but we don't get to see the outside sky. And that's one of the things I hope that you recognize and correct in your life, that you become more observant of nature around you. I mean, life is a participation sport, and you need to go out and enjoy it while you can. So why do we only see one face? Does this mean that the moon isn't rotating? And you could actually make a comment that if it doesn't rotate with respect to us on the Earth, but it does in reference to the sun. So the lunar rotation matches its revolution about the Earth. But then you have to believe that the Earth is not the center of the universe, unlike some creationists would tell you, and that the sun indeed goes around the Earth. So you would have to resolve that issue as well. But this is an astronomy class, and so we're going to go with the standard scientific means of describing the world around us. Phases of the moon can be characterized in this using this picture. The moon is lit up by the sun. And only half of it is lit up. The other side is dark. That's where the shadow is. And as the moon revolves around the Earth, then one face of the moon is always going to be lit up, and the phases are caused because of our position relative to where the moon and the sun are and where that shadow is. So this line cuts a view of, this portion is dark, this portion is light, so this is a crescent phase that we're going to be seeing as exemplified by position B here. So when we look from here on the Earth towards the moon, we see a half of the moon that is cut this way, and this cut is not the same as this cut here, which represents the light and the dark halves of the moon. Notice also that the dark side of the moon we sometimes see, unlike what you might think about in regards to the Pink Floyd record, which is one of my favorites. You can demonstrate this, and I have in my face-to-face classes. You can get a bright flashlight and shine it on a ball and change your orientation of it with respect to you. And if you're doing it with audience, your representation has to include them as well. They represent your position on the Earth, and your flashlight and the ball represents what the sun and the moon are doing. So, and what I have them do in class is draw what they see. On YouTube, you can take a look at this video here, which describes how you can do it at home. So you need a bright incandescent lamp, preferably, and a styrofoam ball with a pencil holding it, and again, you represent the Earth. All right. Now that you're experts on the phases of the moon, then you should be able to answer this question here. What time must the moon rise? And what time does the sun cross the local meridian? Remember, the local meridian is defined as the imaginary line that runs from the North Pole to the zenith point to the South Pole. And then the final question is this: is this a third quarter or a first quarter moon? Now, one of the things I didn't talk about is this thing here. This is a new moon, this is a full moon, although when you look at it, it's only half lit up, right? And this is the first quarter. Well, why is it the first quarter and not a half moon if this is a full moon? Well, it's the first quarter of the orbit. second quarter of the orbit, third quarter of the orbit. It's kind of one of the strange things astronomers do. Anyway, now we'll talk about eclipses. Eclipses, the first one up is a lunar eclipse, and it's when we have a full moon and the moon manages to go into the Earth's shadow, and it takes a certain amount of time for it to go in and out. I think the overall time is about 3 hours. In more detailed, again, the sizes are exaggerated here, and the moon it gets darker here, but then it really gets dark here, and the moon turns a blood red. It's kind of peculiar that way, and we'll talk about that in the next slide. But on this particular picture, I want to show you how you can figure out the size of the moon relative to the Earth. And so put some circles on here. You can see that these circles match the moon and the Earth's shadow. And then we'll come over here, and progressively you can see that the moon is about 1/3 the size of the Earth. Now, why is the color red? Well, this is an eclipse, one that I got to see. I think it's Michael Beckage runs a star party at Seal Beach, which is in the Los Angeles area. And this is time-lapse photography of what we saw. You can see the Earth's shadow creeping up on here, and then when it covers it up, then your eyes become more susceptible to seeing the red color. So this is, he took a longer time exposure here than over here. But your eyes pick it up pretty readily. Why the color? Well, I'll let the cat out of the bag. It has to do with the atmosphere.
Like clockwork, the full moon appears every month in our sky, a sight so familiar that we often take it for granted. But about twice a year, over the course of a few hours, the full moon sports a decidedly different look. What causes this sudden change? A lunar eclipse occurs when the moon passes through the Earth's shadow, just as a solar eclipse occurs when part of the Earth passes through the moon's shadow. But the moon circles the Earth every month as it cycles through its phases, lining up at both full moon and new moon. So why don't eclipses happen twice a month? The reason is that the moon's orbit around the Earth is tilted relative to the Earth's orbit around the sun. Although the Earth and the moon always cast long shadows, they rarely shade each other thanks to the moon's orbital tilt. But if that's the case, why do eclipses happen at all? Throughout the year, the moon's orbital tilt remains fixed with respect to the stars, meaning that it changes with respect to the sun. About twice a year, this puts the moon in just the right position to pass through the Earth's shadow, causing a lunar eclipse. As the moon passes into the central part of the Earth's shadow, called the umbra, it darkens dramatically. Once it's entirely within the umbra, the moon appears a dim red due to sunlight scattered through the Earth's atmosphere. In fact, if you watched the eclipse from the surface of the moon, you'd see the sun set behind the entire Earth, bathing you in a warm red glow. Back home, you'll have to stay up late to watch a lunar eclipse, but if you do, you'll see the moon in rare form, and you'll catch a brief glimpse of our own planet's long shadow.
Okay, so for a solar eclipse, you saw that the Earth and the moon have a long shadow. And in the solar eclipse, what happens is the moon gets in front of the sun with respect to us. There are several types of lunar eclipses. Solar eclipses. Partial, annular, and total. And sometimes the moon completely covers up the sun. Partial eclipse here, partial eclipse there, and this is an annular eclipse. The annular eclipse is due to the fact that sometimes the moon is closer to us or further away. So what happens is we get a ring here, and in this particular case we get the whole thing covered up and we don't even get to see the sun. Now the eccentricity of the Earth of the moon's orbit about the sun is such that there's a difference of about 10%. So and then there's the inclination. The inclination causes us not to see a lunar or solar eclipse every month. Okay, so this is partial eclipse from back edge. You can see a couple of sunspots here and prominences on the limb of the sun. You can see these if you look at with a telescope, an H-alpha filter telescope. And here's a picture of an annular eclipse. I got to see one a few years ago in Bryce Canyon National Park. That was a pretty amazing thing for me, and it got distinctly colder when the moon was in front of the sun. Here's total eclipse. I have not really paid attention to looking at a total eclipse in the past. I have seen some that was in San Diego, but just didn't really pay attention. The corona is supposed to be an amazing sight. As I said, I haven't seen it, and it's so amazing because you see the significant, amazing ability we have with our eyes and the contrast associated with it. We don't get that with our instrumentation. Diamond rings and Bailey's beads are caused by the sun going through mountains and valleys, particularly valleys on the moon. And here's again the corona. If you look at the Earth and you're looking at the shadow that the moon is displaying on the Earth, this is about 60 kilometers in size, so it's not real big, and it's moving quite readily. I forget the speed, but I think that you can find that. This is a picture, I think, from Skylab or the International Space Station. We don't see a lunar eclipse every month. Let's see if we can get this animation to play. And the reason that we don't get to see a lunar eclipse every month is that this is a two-dimensional picture that we normally see, but it's a three-dimensional effect. So the moon's orbit is tilted with respect to the Earth, and not all the time is the shadow or the positions of the Earth and Moon in the right place at the right time. This is going to be an amazing sight. You got to go see it. No two ways about it. The joke is, if you don't go and see this and show me evidence, then you're going to get a retroactive F in this class, which means that you could get a retroactive F in your medical school and you'll fail medical school. You've got to go see it. We rarely get to see these amazing astronomical sights, which were commonplace observations for our ancestors. Again, we are disconnected from the reality of nature. All right, so why do we only see one face of the moon? Well, it's essentially tidal locking. There are lots of
in 1959,
other
the Soviet
objects
spacecraft Luna 3
in the solar
beamed back
system
images
that
of
are
something
like this.
Earthlings had never before seen, the far side of the moon. We always see the same old side of the moon because the moon rotates exactly once on its axis each time it orbits Earth. If it weren't spinning at all, we'd get at least one 360-degree view of its surface with each lap. If it were spinning twice as fast, we'd also see the moon's entire surface more than once per orbit. But instead, our moon's motions, like the spin and orbit of most other moons in our solar system, are remarkably in perfect sync. This wasn't always the case. Our best guess is that our own moon formed due to a massive asteroid impact, and its initial spin and dizzying 10-hour orbit were almost certainly not in sync with each other, though we don't know which was faster. At such close range, Earth's gravity deformed the moon into a slight oval, with one of its bulges facing Earth. Those bulges quickly swung out of alignment thanks to the moon's asynchronous spin and orbit, but Earth's gravity continually squeezed them back again. What's more, this gravitational tugging would have influenced the moon's rotation rate. If it was spinning more than once per orbit, Earth would pull at a slight angle against the moon's direction of rotation, slowing its spin. If the moon was spinning less than once per orbit, Earth would have pulled the other way, speeding its rotation. Whatever the case, it took just 1,000 years for the Earth's pull to adjust the Moon's spin enough that one rotation of the Moon corresponded to one trip around the Earth, leaving one side forever locked facing away. We do end up seeing some of that far side because the Moon's elliptical orbit gives us peaks beyond its average eastern and western horizons, and its tilted axis causes moon seasons, revealing more of the lunar north or south poles. But those glimpses only add up to an extra 9%, leaving 41% of the Moon hidden from Earth. Satellites, starting with Luna 3, have allowed us to map the rest, but it's safe to say that our relationship with the Moon is still pretty one-sided. I'd like to say a big thanks to Squarespace for supporting this episode of Minute Earth. Squarespace is an incredibly easy way for you to create a beautiful website.
Okay, so with that being said, hopefully you've gotten something out of lunar or our view of the moon. We've discussed the phases and lunar and solar eclipses. Okay, thank you very much.